So today I am going to show you each and everything whatever we did until now. So I'm giving you very fast review. After that we will go on the next topic. So let's start. The first thing we learned about computer architecture, how computer works. So as you know, all computers can perform three fundamental actions: storing, retrieving, and process data. Of course, in order for computers to be useful, and the first thing you should know what is input, what is input device, what is output device. So input means you are giving something to the computer. What you are giving to the computer, it can be data, it can be any information you are providing to the computer. It will be input. Okay, and what computer is giving you something, like computer is giving you something, the result. Okay, so you can see in the diagram there is input, process, and output. One more thing you should know about the input and output. What are the input devices and what are the output devices? So input devices, the device you are using to give input to the computer, like keyboard, mouse, scanner, microphone, and these are input device, the devices what you are using to give input to the computer. And output devices, the device you are using to take the output from the computer, like the printer, speaker, monitor. Means computer is giving us something through these devices. So computer works on these three, you can see here: input, process, and output. Okay, and when you give some input to the computer, then computer start process. It's like I ask you some question, that's mean I am giving input. You are thinking, this is the process, and when you are giving me the answer, this is output. So like this, when we give something to the computer, we give some data or information to the computer, so it's input. Okay, after that, computer process through motherboard, through CPU, through network cards. Okay, it can be anything, means from these things the computer process the data. Okay, also the computer process through storage devices, primary storage, like secondary storage, like your hard disk. Primary storage means the RAM, random access memory, ROM, read-only memory. Okay, and after this process, computer give us output. The computer give us the result. So as I told you, input devices move data from the outside world into the computer. These include your keyboard and mouse, like I gave you example. Okay, the main memory unit holds both data and instructions. I'm talking about the main memory. Okay, so this memory. After that, if we come in CPU, so what is the CPU? The central processing unit, or CPU contains two subcomponents which forms the heart of each computer. The arithmetical logical unit, ALU, that is capable performing arithmetic and logical operation on data, and the control unit that ensure that all the other components work together to execute the instructions. Okay, then there are some bus inside the computer. If you have seen the computer from desktop from inside, so you will find different types of cables. The data travel on these bus. So all components are connected to one another by the collection of wires called the bus, through which data travels within the computer. I mean, inside the computer, how data travels with these wires. The output device, as I told you, output device move result from inside the computer to the outside world, like your monitor or printer. After that, we come on the fetch execute cycle. We learned about this, that you are familiar with the main architecture of a computer. So let's see how the instructions are executed and process data. This is also known as the fetch execute cycle. Remember that both data and instructions are stored in the main memory. Okay, so you can see here, fetch the next instruction, the CPU retrieve the next instruction to be executed from the main memory and store it in a special type of local memory inside the CPU, which called register. We call register. Okay, so you can see here the newly processed is written back into the memory location on the HDD and SSD. So the result of the execution of the instructions are stored in the main memory. And what is decode? You can see here what is decode. Decode the instruction, basically the control unit interrupts the current instruction, which is the instruction register, and transforms it to a control signal that can be understood by ALU, arithmetical logical unit, what I explained to you now. And after that, execute the instruction. Once the instruction is decoded and all required data fetch, the ALU, means arithmetical logical unit, carries out the execution of the instruction. So most usually involving operations or various registers. So this is the fetch cycle. You can see here is store, here is execute, but before this we decode. You can see here the CPU determines which system components are required. Okay, so after that it's outlining parameters for a successful execution, means it execute. After that, here is fetch. I explain you the CPU retrieves instruction from a system hard drive or solid state drive and store them in a register location. So this is the fetch execute cycle. After that, we talked about the main memory. The type of main memory that all the computer use is called RAM, which stands for random access memory. So you can see this picture. This is the random access memory, and there are the slots inside the system, and we put this RAM inside the motherboard. Okay, you can see here there is a um, chips, and also there are some cuts. Okay, and the same cuts you will find in the slots. So this means that each byte of data inside the memory can be directly accessed and altered. RAM need to be very fast so that it can support rapid access of data and instruction. RAM is also is volatile memory. Volatile means temporary memory, means its content are only maintained for as long as the computer is powered on. If you are working on the computer, everything will be stored in the RAM. But once you close your computer, the RAM will be empty. But if you are working and you store your data, so it will move from the RAM to the hard disk. So a common example of such memory is a flash memory or on USB memory sticks. Okay, so this is a very common example. The data is stored after we unplug the device from a computer, but access to data is much slower. Again, I will say this is the temporary memory. It works until our power off, computer power on. After that, we learned about the secondary storage. As we already mentioned, the main memory is the volatile. It works until our powered on, our computer is working. Okay, so the main memory is volatile or temporary and limited in size. So we need another type of storage device where data and instruction can be kept safely when they are no longer being processed, or when the computer is turned off, the data will be stored in the hard drive, as I told you before. If you save your data, so it moves to the hard disk. Okay, so these are the devices, these are the other types of devices are called secondary storage devices. And The most well-known include the hard disk drives and the CD drive because data must be read from them and written to them. Secondary storage devices are considered both input and output devices. Okay, so this is our secondary storage. So the hard disk, a desktop computer, can have one or multiple hard disk drives connected to it. You can see this is the picture, this is the diagram of the hard disk. The main principle of the operation of a hard disk is read and write head that travel across a spinning magnetic disk. This you can see here. This is the disk, and there are tracks. The surface of each magnetic disk is logically organized into tracks and sectors. A track is concentric circle on the surface of the disk, and each track is divided into sectors. Each sector contains a block of data as a continuous sequence of bits. So in the hard disk, this is a seek time, latency, access time, and transfer rate. What is seek time? Seek time basically is the times it takes for the read, write, head to get position over the specified track. What is latency? Is the time it takes for a specified sector to be in position under the read and write head. What is the access time? Access time is basically the time it takes for a block to start being read. The sum of seek time and latency. And what is transfer rate? Transfer rate is the rate at which data moves from the disk to the main memory. So now, as you can understand, different applications have different needs. For example, a database system needs fast access times as it constantly read and write thousands of records that are positioned all over the disk. Okay, so actual hard disk drives that can be found in our computer consist of several magnetic disks called platter. So remember what is platter? Our hard disk drive that can be found in our computer consists of several magnetic disks called platters, one on top of the other and each with its own read and write head. Okay, so it was our hard disk. So students, other secondary storage device include optical drives like CD, DVD or Blu-ray drives. So these devices read and write data optically from the plastic aluminum disk using a laser beam. In writing mode, the later being series of pits. So on these images, we can computers, you can see this is our disk. Okay, and in this disk, this is very sensitive basically. Okay, like your game disk. If you put the disk for on PlayStation 4 or Xbox or whatever device you are using for play. So when you put the disk, if there are the scratches, so means it's uh, not scratches only on the disk. There are the sectors, there are the tracks. So it damaged these sectors, these tracks. So that's why sometimes our disk doesn't work or it doesn't give us, it's stuck, it's lag. Okay guys, so after this we learned about the operating system. For the operating system, you should know before Windows we were using DOS, and this is the image for the DOS disk operating system. Okay, there was thousands of commands, and for every action, if we have to delete, if we have to change directory, if we have to make directory, for everything we were using commands. So that's why we called CUI. DOS was the CUI. What is CUI? CUI means command user interface. User means you who's using the computer. Interface means the communication between you and the computer. And commands means you are giving commands, you are giving instruction. So we called CUI because this was command user interface. And what is Windows? Windows is GUI, graphical user interface. So in the previous task, we talk about the internal components and devices. So all these parts from the transistors form the hardware of the computer. Okay, now what is hardware and what is software? So the physical components of the computer is called hardware. The things you can touch, it's hardware. And what is the software? Software means the things you cannot touch, like all your games, all your um, applications, these are software. But in modern software is divided into two categories: application software and the system software. Now, what is application software and what is system software? So you can see this picture, the application software, it can be your computer game, spreadsheets. Spreadsheet means the Excel, Word, Microsoft Word, all your database, internet browser, all these things will be application software. And what about the system software, like the operating system? Like in the mobiles, you are using Android, it's operating system. Like before, we were using the operating system DOS, disk operating system. Okay, but now the operating system Windows. So in the system software, what the software we are using to run the computer. Okay, and if we come in the hardware, so again CPU, disk, mouse, printer, etc. So guys, as I told you before, there are two types of network we learned: LAN and WAN, local area network and wide area network. Local area network basically we use inside the building, inside the office, inside the school, like in our computer lab, we are using LAN, local area network. There is one server and all the computers are connected with that server, okay, with cables. If we talk about the WAN, so WAN is the wide area network, like your uh, network on Wi-Fi, what you are using. So you can see this diagram, a networking model is only a representation of a network operation. The model is not the actual network, okay? So these are the application, presentation, and data link, physical, okay? And what is HTTP? If we talk about www, the first www, World Wide Web, means you are connecting with the world. If you have LAN or WAN and you are writing in the browser www. Suppose you are creating account on Google. So when you fill that form and you click submit, so it goes to the server. Every company, every organization, every website, they have their own servers, okay? And who takes your request to the server? HTTP. HTTP is the one who takes your request to the server. HTTP means Hypertext Transfer Protocol. So he takes your request to the server and it comes to you. If this name is already exists, what you are making, you want to make an account um, on Google. So HTTP take your request when you submit to the server, and very fast it comes to you and tell you this name is already exist in the server. So guys, these things we learned in the last chapters, and one more thing we learned about firewall. So firewall is basically a software or hardware based network security system that controls the incoming and outgoing network traffic by analyzing the data packets and determining where they should be allowed through or not. So it gives you, okay guys, so firewall create a security barrier that separate and protects a single computer or a local network from the internet. A firewall creates a security barrier that separate and protects a single computer or a local network from the internet. You can see this diagram. This is our wall, and this is the outside world, LAN, and this is the local network, LAN. So it protects and secure the computer network from the internet. So you can check your own firewall. Microsoft Windows comes equipped with the software firewall. It's already in the Windows. So make sure it is on or turn it on if it isn't. You can click start and then click on the control panel. In the search box, type firewall and then click Windows Firewall. If everything is green, then your firewall is enabled. If the firewall is off, click turn Windows Firewall on or off. After that, select turn on firewalls on all your networks and then click OK. So this is the process. So now we we revise all the things what we did until now, and now you are ready for test.